All right, so adding scalar multiples of vectors graphically. Draw the vectors indicated. You may use any extra unlabeled vectors that are helpful, but keep in mind that unlabeled vectors should be deleted before submitting your answer.
I don't even know how to put the vectors on or anything.
Yeah, I think you just drag and drop maybe, I don't know. Oh, right, add element. So draw vector C, which is just vector A plus 2 vector B's. Okay. So let's do that on the board.
Huh? So we're just showing one vector?
Yeah, I just want C.
Yep.
Oh, wait. So just like the height. Oh, that's why they were saying do the other two, but then you can delete. Make sure you delete them.
Yeah, so in this case, it's not going to be beneficial to add any more vectors.
Mhm.
Later on, I would imagine they're going to start giving you some vectors that are at diagonals. And then it's like helpful to draw the components. But in this
Okay.
case, they're both completely in the x-axis. So it looks like vector A is doing that, and vector B is doing that. This one's 3 units long, this one's 1 unit long. And they want us to figure out A plus 2B and figure out the resulting C vector. So all we would do for that is we would just do tip to tail method. You guys have talked about that.
Yeah.
So we'd start with vector A, we would draw it out, and then we would draw 2 vector B's tip to tail style. So here's the tip of A, if we start the tail of B right there, we'd go back 1, and then draw another B, go back another 1. And then to find our resulting vector, we would take our first point, connect it to our last point, and so vector C is just going to look like this. It'll just be a vector that's in the x-axis. It could be anywhere, but it will just be 1 unit long and it will point directly right.
Oh, so it gives you. I get it now.
So
it gives
okay.
you like the.
And it's just 1 unit long? See, I don't really know how to like use
Oh, no, sorry,
like,
'cause-
I don't know how to
A is 4 units long.
Oh yeah. So it's gonna be
Yeah, so
2.
you go 4 units right, and then 1 unit left, and then another unit left.
So it's gonna be 2 units long.
Exactly.
Okay, but so when I like wanna add a vector, how do I oh, there we go.
Yeah, there's got to be some sort of drawing tool. Or,
Yeah.
There you go. And then label it vector C, and that should be all at once.
I get it now because I thought.
Yeah,
Give me
that-
a graph, so I thought you had to just like make it up. So
Oh,
I was
gotcha.
so confused.
So like this one gives us a
Slanted one.
slanted one
Okay, so yeah, let's do that one.
for
Which part is that?
it's part B.
Okay.
That makes sense now that it doesn't have to like make it our You're like trying to make this.
Yeah.
This wasn't working well.
So now they want you to find vector C, which is equal to
1.5a minus 3b.
A minus
3b.
3B. I'm going to go ahead and change that to plus negative 3B. Because if we change it to an addition problem, then we can use tip to tail method. So we just need to keep in mind that negative 3B is going to be the same thing as just regular 3B, but it'll point the opposite direction. So right now it looks like B is pointing left, but in our mind we'll just think of B as pointing right from now on, because we switched it to the negative version. So here's our coordinate system. And it looks like we've got A going off at some weird angle like that. And then B is like that. So the first thing that we'll want to do is take vector A and split it into x and y components. So here's the x component, and here's the y component. And so on your graph, it looks like the x component is 1, 2, 3, 4 units long. The y component is 2 units tall, And vector B is 1 unit. Okay. So now we need to figure out what 1.5a would be. So if we take the x component of a and we multiply it by 1.5, what's 4 times 1.5?
6.
Good. So we would take, so let's say that's about 6 units there. And then the y component, 2 times 1.5 is going to be 3. So here's 3 units. So we're just drawing our vectors tip to tail style. So here's our first vector, 6 units long. Our second vector, 3 units tall. And now we need to add 3 negative b's. So originally b went in the left direction, now we want to think of it as going in the right direction. It's 1 unit long. So here's a unit, there's the next one, and there's the third one. So this was 3 units, 1, 1, and 1. So now if we add everything together, it looks like we're going to have 9 units to the right and 3 units up. And our resulting vector is going to be the line that connects those starting and ending points. So 9 at 3. Pythagorean theorem, you take 9 squared plus 3 squared, and then take the square root, and you get
So 27.
27. That doesn't seem right. So 9 times 9 is 81, so 90, what's the square root
Oh,
of 90?
I did, sorry, I multiplied them instead of,
Oh, okay.
this way. So it should be 9.5.
9.5. So then we just have to draw that vector.
And it's gonna be going diagonally.
Yeah, so it'll go diagonally, so you want to make it go 9 over and 3 up, pointing up and to the right.
Does it matter where I put it?
Nope.
I think it does.
Because yeah, vectors, as long as we keep the magnitude and the direction conserved, we're allowed to pick them up and move them wherever on the xy coordinate is convenient. But we just can't stretch them or shrink them or turn them.
So part C is like part B. It had like another angle, like a diagonal. It has 2 diagonal ones, I guess.
Yep. So do you want to do that one, or do you think you guys want to move on to a new type of question?
Sure.
Um, So this was like another like misconceptual one or whatever. But we just couldn't get part B, so we got part A. And then for some reason we can't find the components of vector B. Because he did this one in class for us even, but when I went to put in the answers, it said it was wrong for part B.
Okay. So the question says, often a vector is specified by a magnitude and a direction. For example, a rope with tension T exerts a force of magnitude T in a direction 35 degrees north of east. This is a good way to think of vectors. However, to calculate results with vectors, it is best to select a coordinate system and manipulate the components of the vectors in that coordinate system. Okay, so here's a picture.
Now I have to, yeah.
I'll let the expert do it. Oh, there you go.
Yeah, there we go. Oh, okay.
That's fine. You can full screen.
Was it
That
better full screen?
No, that looked okay.
Okay.
All right.
Computer screen is-
So you guys already did part A. What was part A asking?
Yeah, it wants of components for vector A, which we did these in class because he did them
Okay.
with us. And we got the right answers in class,
Oh, yeah.
but for part B, for some reason, they weren't the right answers. But we
So-
did it how he told us to do it.
Find the components of vector B with length B equals 1 and B equals 20 degrees with respect to the x-axis.
Oh, is it 20 degrees?
Did you do something else?
I put 10 degrees.
So that's probably the,
why. Okay, well, that's.
so yeah, so we
well,
just got,
I know how to do it. I just
Okay.
couldn't figure out why we were getting the wrong answer when that's how we were doing it in class. But if I put 10 degrees, that's why.
cool, so,
That's,
and then part C, it looks like it's the same thing, so just
Yeah.
more splitting into components.
yeah,
So no problem, you guys got that?
yeah.
Okay,